Does anybody have a question to start? Or should I just start according to the plan? I wanted to show you the how the template language works first.
Yep.
But if there is any question that relates to the first part, I can do that first.
Yeah, feel free to ask any questions. I will ask them, Kyle. I don't see any question at the moment, so feel free to share.
Okay. Okay. The first thing I would like to show it is what happens with the aspects and the templates, because I hope it sounded like magic. It's really meant to be like this. Of course, it is just very difficult and not magic. So when you compile the app, or actually when you click I'm done with the changes, the first step that Metalama will do is to separate your project, because you have two kinds of files. In your project, you will have files that are runtime. This is most of your code is runtime. And then you have build time files. I didn't show them. And then you have aspects. And in aspect, you have some parts are runtime and some part are compile time. So the first thing that Metalama does is to extract the compile time part from your project and to compile the template. But here, what we call compilation is not to compile into IL. First, it needs to compile into code, into C#. And here you see, this is the code that is generated from the first example. So this line, console.write line, entering blah 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 blah. This line is transformed into this sequence of code that you can see here. And these are calls to Roslyn. Mostly this is the Roslyn API, and this is the with some calls to the Metalama API. So let's see that, because these show you how Roslyn works. So let's look at the code to do an invocation of console write lines. So we are going to start here, and we are creating an invocation expression. This is a member access. So we are not going just to write system console write line, because we don't know which namespaces are defined in the target file. So actually what we are doing is to fully qualify the call. So we start with global, with the global keyword, :token, and then system identifier dot token, console identifier dot token, write line identifier. This is really Roslyn API. It's just made unreadable because this file is not done to be read by humans, so it is not simplified. It is as it is generated. So then we have the arguments list. And here you see the one argument is a string literal expression. And here you see within this runtime expression, we have the compile time code. This is just here, it is just fully qualified. So you can understand how the templating works. Like anything that looks like runtime code, it's actually compiled into an expression tree like this part. And anything that is build time and is highlighted in a funny way, well, this is actually not transformed at all, or very, very little transformed, which is quite counterintuitive, because we would think that the complex part is actually the runtime, the compile time part, and not the runtime part. But no. So we have what we call the template compiler. It's a very, very complex piece of software, and the job of this template compiler is to generate this code from the template code.
So
okay.
if ask you a question myself, so you have the original C# code in your aspect. You can use that to generate this, but then this code runs a compile time to generate the final code that is a standard that
Exactly.
you will check in into GitHub or whatever. Yeah.
To generate the final code that you do not check to GitHub.
Oh yeah, you do not check it to GitHub, but it's the one that actually run. Yeah, at the end.
Yeah, this is the one that actually runs. So the first step in the compilation with Metalama is to generate this file. Then it is compiled into a DLL. It is loaded dynamically by the compiler or by the IDE process, and then when we see that we have an override method advice, and maybe you remember that it is given by name. I don't know if it was visible in my examples, but anyway, every template has a unique name. You cannot have templates with the same name and different signature. So the Metalama pipeline will call this method, and actually it gives some context, and it returns a syntax node. The syntax node is going to be a block, basically. So this is one of the most complex parts. There are two complex parts. This is one, and then the second complex part is what we call the linker, that binds everything together, because you have all the different pieces that come from different aspects, and then the linker is a very complex part that relinks everything together. And I cannot show code here because it is not written to disk. I need a special tool. Well, if someone is interested, I can also show that, but it's not prepared. So that's the first part that I wanted to show.
There's a quick question that also this looks a little bit scary. So there is someone, Arnold, in asking, like, I'm relatively new to C# and .NET. Is it appropriate or wise to try to learn and use Metalama or program normally and then apply the magic of Metalama? Or what?
I would. Well, it's not a matter of .NET knowledge, but it's rather a matter of object-oriented programming knowledge. So if you are new to object-oriented programming, I would not recommend starting with Metalama or with metaprogramming, because first, well, you should use these tools when you have exhausted the possibilities of object-oriented programming, of dependency injection, of design patterns. There are some design patterns are good. They don't require boilerplate code. So what I would not like you to do is to start using this tool because it is cool. It's kind of something that you would use in last resort when there is no other approach, because there is a cost of using that tool, is that you are adding some complexity. Now this complexity can pay off because it removes another layer of complexity, but you should use that only if it really pays off compared to standard techniques. That's my long answer.
Pretty honest answer. Thank you. Appreciate it. Yeah, feel free to continue.
I can go to the second thing I wanted to show. And these are Roslyn extension points. We'll switch to another desktop here. Okay. So, Roslyn, this is the C# compiler, the managed implementation. It has a few extension points that Metalama has implement. And first, I will show the ones, the standard ones. They are split into two projects. So this is our this is the implementation of the framework. All these projects, we have more projects, but these are those for the latest Roslyn version. And these are the entry points for Roslyn. And here you can see, I will talk about three first. The first standard extension point of Roslyn are the diagnostic analyzer. So a diagnostic analyzer is something that reports a diagnostic. So it has basically one method which is, well, initialize, and then you say what you want to initialize. Here it's a bit more difficult here because, well, it is not the typical implementation. We are plugging for each kind of process, we are plugging a different implementation. So let's look at the implementation we use by default, the diagnostic analyzer. Yes. So typical, this is typical. We are registering an analytic action, well, an analyze method, and here we are asking to analyze the semantic model. And you get a context. Well, we added a layer to make it testable, but basically what you get here is something that allows you to report a diagnostic. This is the essence of a diagnostic analyzer. So it can do one thing, really just one thing, report a diagnostic. Now you have diagnostic suppressors. This is the second entry point. And the feature of a diagnostic suppressor is to cancel, if you want, is to cancel warnings. So I didn't show how this was used, but sometimes you have warnings like, well, this member is not used, because actually the compiler inside the IDE, when it runs in real time, it doesn't see the code that is generated by the aspect because we don't generate it in real time. So you need to say, well, this warning that the field is not used, well, you can remove it. And so that's another entry point of Roslyn, and the main action you can do is to suppress a diagnostic. Then we have source generators. This is the third entry point. I will show you. Let me switch to VMware. I will show you source generators. So, and actually I skipped that. So I should have stopped and made a point, which I didn't do. You see here, even if you cannot see an ID property, but here you can reference it, and you can see that in IntelliSense. And this works at design time because the class is partial and Metalama generated a partial class. Now, if you go to Metalama framework, no, sorry, here, Metalama In the analyzers, you can see compiler extensions as a project I had. And then you go down, 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 down. And here you see code generator. And you see that Metalama generated this part in real time. It didn't implement everything. So you can see here there is no field initialization. We don't call interlocked, but we do generate the members. So to generate these files, you need to call a source generator. And source generator, this is the most complex of all. And we use that at compile time to enable the design. No, we use the source generators at design time, sorry, to enable for the design time experience and code completion and so on. So that's another entry point. No, that's not all. There are things I didn't show, but in Roslyn, you can have code fixes. You can provide code fixes, and you can provide source code refactorings. I will just show you in another example to show how this is put in action. And for this, I need to find a way to collapse this thing. Yes. Code fixes, it is in my attic. Yes, okay. Here is an example where we have a toString attribute. Okay, and we can add the toString attribute as an aspect if we want. This is the interpolated string builder, quite similar to logging. We are adding everything, and this introduces the method called toString. Okay, but now instead of adding that as an aspect, I can add this as a live template. You see that it generates. So the aspect is applied, but not as an aspect, but as a template, because an aspect, by definition, does not modify your source code. By definition, it runs within the compiler pipeline, and the whole point of the aspect is that you don't have that code in your source code. But actually, since we are there, since we created all this templating system, well, we can also modify your source code. So that's what we propose here. If you want to propose that to your users, you do suggest as live template. And then there is another scenario, and it is to suggest things to the user. And for instance, here I have toString here, and I can see that it generates toString. And my case here is that I don't want, well, you see all the properties. I want to exclude velocity. But my users don't like to read documentations, and I would like to propose some code fix. So, okay, this is something that the aspect defines. And by the way, well, what if I need to implement myself? I want to switch to a manual implementation. Okay, there was some problem. Let's redo that. I want to switch to a manual implementation. No, okay, I will not show it today because there was a bug. But that is supposed to work. So the way that these things are implemented, let me go back to this desktop, is that we implement the code fix provider and a code fix refactoring provider. And this is how we are able to push the code fixes of the aspect to the UI. So the aspect, what it needs to do, let me go to the aspect. It needs to suggest a code fix. So the build aspect method suggests a code fix. But eventually we need to publish that to Roslyn using code refactoring provider. So that means that one single aspect actually may potentially implement all these extension points of generating code, providing, so generating code, reporting warnings, suppressing warnings, what else? And providing code fixes if you want to get the luxury version, if you want to build a luxury experience for your users. So you would need to go and integrate with all these APIs. But these are the official APIs. But there is a gap. There is something you cannot do with the Roslyn APIs, and this is to replace some code with other code. So you can add new code. You can add a new partial class. That's okay. Well, T4 was also able to do that. But you cannot modify a method, for instance, to add logging or to edit a property to call on property change. This is not possible. So what we did is that we have a fork of Roslyn. And this fork of Roslyn defines another extension point that we call a source transformer. This is the source transformer. It has this transformation context. And the transformation context allows you to add new syntax trees. This is nothing new because source generators can do the same. But you can also, where is that? You can also modify a syntax tree. That means you can replace an old one with a new one. So this is not possible in the version of Roslyn maintained by Microsoft. So we have a fork that is called Metalama compiler. It is public, open source under the original MIT license. And we added this extension point, which was a couple of months of work in the beginning. And now it's rather 1 or 2 weeks of work per year to integrate the changes back. So this is actually very maintainable and convenient. So that's essentially how Metalama works. So at design time, we run within the Visual Studio process or the Rider process or the Visual Studio Code process, but we don't control the compiler. It is a part of the IDE. We cannot run or fork. So this is where we are running the analyzer, the suppressor, the source generator. We are running all these things here, and we are running the in the IDE, the code fix provider, the code refactoring provider. So, but at compile time, we are not running any of those. We are only running the source transformer. That's the only thing we are running because it does everything. There is an API to report errors, to suppress errors, to replace code, and to add syntax trees. Basically, we are running two, well, the software with two different sets of entry points. One are the design time entry points, and the second are the compile time entry points. Any question to this part?
I'm pretty sure you have some question. Come on.
You know, there are two kinds of no question. The first is no interest, but we went past this point because this was in the first part of the webinar, and then the second is that it's too difficult.
It's overwhelming. Yeah,
Too
it's quite complicated.
Yeah.
It's quite impressive.
Yeah, here we are getting in the business of building metaprogramming tools. Like,
Yeah.
So what we are doing as a company and as Metalama is to make metaprogramming easy for developers writing business software or scientific software. But actually, to implement that, you need years of investment to make this complexity simple enough for like business use.
Yeah,
That's what we are doing.
interesting. It's a philosophy very similar to what we have at Regate that we call ingeniously simple, right? We have products that are easy
Yeah.
to use, but building them, like all the profilers
Yes.
and stuff,
Yes.
is super complex. So yeah,
Yeah.
I can say Rui, it's complex and impressive at the same time. Um, how out of curiosity, how in terms of how documented is like Roslyn? Like if someone want to play with it, or in general, like, or do you just need to use IntelliSense and
Well,
mess up?
there is a class reference. So you can read things, but it is not documented as the .NET framework.
Mm,
I would rather say it is. So for the basic things, like you will find examples about how to do a code fix provider. If I hit F1, you will see some basic class reference. And so that's okay, but this is really the surface of their API. Then if you go deeper, it is not so well documented, but overall Roslyn is very well built. The quality is very high and everything is very consistent. So um, so it's generally not a problem to use that. Um, when there is a problem, then of course you can step into the code
mm,
and it gets more complex.
cool.
But I couldn't say that we are hitting problems because of lack of documentation.
Mm. There's a question about compatibility. Is this with compatible only with C sharp, or can be used with F sharp?
No, it's only C sharp
Only C sharp.
because it's this is purely based on the C sharp syntax.
Yep, makes total sense. Rui is asking, is it possible to extend the meta framework, although with constraints? Not sure
I
if
don't understand
I'm sure I understand, Rui, what that means.
constraints. What kind of constraints?
Is it possible to extend the meta framework, although with constraints?
I
If
don't
you
see the question.
if you wanna clarify the questions, Rui.
Uh, I lost the Q&A and the window
Uh,
on all these desktops. No, I don't understand the question. What do you mean by constraints?
let's wait until it
Do you
might
mean
come.
architecture? I don't know.
I mean, for the example of the meta.proceed, one can change its behavior.
Method.proceed is always will always call the next aspect in line. So maybe the question maybe
What
like
meta
what
is
you cannot
posed?
do.
Uh, oh yeah, good
What you
point.
can do with Metalama framework is
Mhm,
to change things inside the method. So you can wrap a method. You can wrap it into a try catch. You can wrap
mm,
it into a delegate call. But you cannot change it inside. It's really a matryoshka. You are building
all right.
features around it. And this is important because it gives you some discipline in writing the aspects. There are two approaches to metaprogramming. One is that you get access to well everything. So this is, for instance, the source transformer API. You can change a node to a node to something different. You can change plus to minus.
Mm.
But um, but at the level of abstraction of Metalama framework, you cannot do that. You have to respect the model that we set, because this is a model that ensures safety and it ensures that your code is understandable.
Makes sense. Yep. It's like,
Now we also have something that we call the SDK, Metalama Framework SDK, and then it opens the Pandora box. So
mm.
you can do everything if you use the SDK, even changing plus to minus.
Ah, okay. Is
But
that
it is less supported. Um, the valid use case for the SDK is rather to analyze method bodies. For instance, if you want to implement notify property change, we want to analyze, to make a graph of dependencies of when one property is changed, which other properties must be notified. And to get this information, you need to get to the method bodies. So you would use the SDK to analyze the method bodies. That's a valid use case, and a use case that I don't promote, but is supported, maybe not forever. And these are the aspect weavers, where you can really do whatever you want. You can replace a syntax tree, run a rewriter against a syntax tree. So here you can do
yeah, no, no.
anything and generate invalid code very easily.
Can imagine. Uh, uh, maybe doing a step backward in terms of like just getting back to the using of Metalama. So what do you think are the kind of the most commonly used use cases of Metalama, like what the things that people mostly kind of use and benefit from?
Like instrumentation for observability that includes logging
Mm,
or some performance metrics. That's one of the use cases. Um, the well, notify property change and all this WPF boilerplate code is another one. I will open here is with PostSharp we we got a lot of use cases with multi-threading, acquiring locks or acquiring reader writer locks. Here we have some list of use cases for which we have already examples.
lovely.
I've seen some customers doing using Metalama for integration when you have integration projects, or you are migrating legacy code from one architecture to the other. Then you may have a lot of boilerplate code to glue these parts, and these are cases that cannot be made as examples, like as public examples, because they are
Niche, like, yeah, more niche.
they are very specific. Undo redo. Here I have an example of the memento pattern. In PostSharp we did another approach, but that's also one of the cases. Well, of course, exception handling.
Yep.
You know, you
Okay.
can you can apply poly, for instance,
Yep.
quite quite simply, um, or
Mm,
a simple use case is to enrich exception stacks with parameter values. That means that when there is an exception, you would append a context frame. For instance, here we are appending a string Okay, I should do full screen. I cannot. Here it's a bit more visible, but so that's an aspect, very simple aspect that can be useful.
Yeah.
Well, you have all the contracts, validating parameters or properties, because you can do that with data annotations when it is on the surface of your app, because ASP.NET MVT has these data annotations. But when you are using tools like Metalama, you can use that in all layers of your app, not only inside. So yeah, contracts are one of those. Can validate fields and properties. You know, sometimes it's very common.
Yeah. Sounds useful.
Invariants are going to, well, if you define an invariant, it will call your invariant after every method, for instance.
Yeah.
This is rather academic.
Lots of
I've
possibilities.
never
Yeah.
seen really.
Yeah. Yeah.
But these ones, most other contracts, they are very standardly used. And of course, caching. So we ourselves inside Metalama, we use extensively memoization.
Hmm.
Well, we have an implementation of the aspect that relies on Metalama compiler, because we cannot use Metalama in Metalama itself. But we can use Metalama compiler in Metalama. And if you take, that's an object that represents a method, you can see all this code here, like memo. Memo ensures that the property is evaluated only once. And it uses an interlocked exchange pattern to make sure that there is always a single instance. This
Cool.
is hugely useful.
Awesome.
So these are standard use cases, but it's a state of mind, because in the beginning you may have just one use case in mind, or maybe no use case in mind, but in this case you don't start. But so if you have this one use case, then you start thinking in a different way, and your abstraction level of thinking starts to be different, and then you start seeing a lot of other cases. And then you can see how useful it can be. We have some telemetry, not from Metalama, but from PostSharp, and we estimate that that typically customers would say 15% of code with PostSharp. Typically, it doesn't mean up to. It means that it is the average saving of the top quartile. So there are a lot of projects where, well, you will not save anything because you don't use properly. Of course, like telemetry shows that. But they are like in 25% of project, they save 15%, and in some cases it can be 200%. Like imagine that you have a project with only these MVVM classes. Like that's huge.
Yeah. Yeah. I know. Even the notify property changed. How many times I had to write the things, and if I forget one of those method calls, like the UI doesn't work as well as you want. So yeah, awesome. There's another question about is there any example of using Metalama with other .NET frameworks like CSLA? I'm sure you're familiar with that.
No, I'm not familiar with CSLA. I'm not sure.
Software development framework.
But what is CSLA? Well,
it's a .NET software development framework that helps to build reusable, maintainable, object-oriented business layer for your app.
You mean with business frameworks on the top? Well, there is no reason it is not compatible. We support .NET Standard 2. So any project that will build against .NET Standard 2 or superior, like it is the lowest, it is not the highest, it's the lowest, of course.
Yeah.
So, and we generate C# code. So that works in the compiler level. There, so actually, anything that compiles is going to work with Metalama. But now it doesn't mean that all the aspects we build will work. You know, for instance, here we build aspects,
Yeah,
for instance, dependency property. Well, it's clear that we build that for WPF and not for MAUI because it's a different API.
yeah. Total sense. Uh, Metalama to generate Blazor components? Question mark.
I don't know. I've never done seriously any Blazor. There is Blazor. You mean
The front
the
end,
client?
the C sharp, yeah,
Well, as long as it compiles,
it's
you
just C
can
sharp.
use
Yeah, I think at the end of the day it's C sharp, right? So yeah.
it is C# that compiles into MSIL. So yes, you can use it now typically to generate components. I would say no, but to generate code within
Mm,
other components, yes, there is a case with web apps. There is a case that we don't support is to have aspect in your CS HTML files. So this is not supported for a good reason. Actually, is that the Roslyn runs all source generators in parallel. That means that we do not see that code. That Metalama doesn't see the code that is in a CS HTML file. But except that limitation, that just works.
is there a way to like generate all the code that Metalama would create and open up in Visual Studio somehow, just to
Yeah,
explore?
completely. Completely. We call that divorce. You know, divorce is not fun,
Oh
but
no,
you are
I know
happy
that.
when you need it. Also went through divorce, and but it's good that it's a possibility. Um, so so we have that feature that we call Metalama divorce. I hope I had some. Yeah. So you have a Metalama divorce command actually. Well, and there is a divorce script even divorcing from Metalama. So what is it going to do? This the script is here. Is that well? First, you would start with a clean commit with no changes. Then you run this. You run the build with these settings set. And what it will do is to generate all files into the obj debug directory. And the next step, so that's this would generate all files. And then this command would write back the generated files to your source code. And because you commented before, you are going to see a diff and you can review every change done by Metalama. And once it is done, you can remove Metalama from your compilation process because it is no longer needed.
But you don't need to do that for seeing the Metalama code because you've done all of the implementation of design time experience to see using the other debug kind of mode that you said. So you can see the code. Yeah, this is mostly for just seeing everything if you want to.
Yeah, well, what this is when you don't want to see the code, but you want to remove Metalama
Yeah.
from your pipeline. So this is the kind of exit vendor lockout. What I would
Hmm.
so I would say no. If you want to just see the code, well, you have this preview that I've shown many times, or you have this llama debug. Basically, you set these two MS Build properties, which is what llama debug does, and then you look under your obj debug Metalama directory, all the modified files will be there.
Thank you. Rui, I'm not sure I understand the question. You're asking, is there any other Metalama gem like that? What do you mean? Metalama gem.
A Metalama gem, like what? It depends on what I was showing at the moment the message was written.
Tool like this one. Oh, is there any other tools like Metalama, you mean?
But Roslyn based, no, on Roslyn based Metalama is the only one. Now, on the previous generation of technologies, also IL based, well, there are basically two. One is post sharp, and the second is FODI. So FODI, so post sharp has the same philosophy as Metalama, where it is engineered for safety and simplicity. And FODI is more a plugin loader that allows you to do anything with MSIL. So you can also change a plus for minus. But most people don't do that. They use pre-made plugins, and there are a lot of plugins. So then there is another approach to aspect-oriented programming that is completely different, and it is based on middlewares. So the middleware approach is when you have a caller and a callee, or an implementation, and they are separate things, and they interact through an interface. So the middleware is to put your aspect between the caller and the implementation. So if you need caching, you would add a caching class that would be an interceptor. It would be implemented typically as a dynamic proxy, which means that at runtime, and not at build time, but at runtime, the framework would generate a class that implements the same interface, but calls your aspect. And then when your aspect calls proceed, it would call the implementation. So this approach works with ASP.NET MVC. These are action filters, and it can work with dependency injection when you use interfaces. And so that's approximately the landscape.
Yeah, so Metalama is pretty unique in that regard in using building on top of
With
everything and
Roslyn
uses
based,
perfect for C# developers. Yeah.
we are the only one. And yeah, but there are 10 man years of work in building Metalama. That's
I can tell.
this is a very a, very hard stack that you cannot get like
That's
you
quite
cannot get
impressive.
that with evenings, with just your evenings,
Oh yeah. Yeah,
like with other projects.
yeah, it's pretty impressive. Awesome. I think this is a perfect time to wrap it up, I think. Just want to say thank you so much for your time, and I'm pretty sure all our production members really enjoyed this. And I want to share the first part of the recording on YouTube and the second part in the kind of production membership dashboard for other people to benefit. And as you probably know, Metalama is a sponsor of C Sharp, and I regularly give away licenses to members. So I will certainly do a raffle to the people attending the webinar fairly soon. So thank you so much. I really appreciate it.
Yeah,
I've learned a lot, and yeah, I can see a lot of people really being really appreciative of your time and expertise. Thank you.
thank you for the opportunity. If you want to move move forward, well, there is this documentation where you will find getting started guide. You will find a few tutorials, documented examples.
I've
You
shared the
will
link in the
find,
chat. Yeah.
yeah, you will find us on GitHub. This is where we have the well, all the source code is there. bugs and every commit is there. We have Metalama Marketplace that you need to know about. The marketplace. This is where you can find aspects that have been made by other people
Right.
and
Quite
you
extensible,
just
yeah.
use that. And there is a free edition that allows for three aspect classes. So you can use, say, login, caching, and notify priority change everywhere in all your projects. And
Oh,
in
wow.
each project, it is a different set of three classes.
Sounds great. All right. So,
Thank you for
yeah.
the opportunity. If you have any question, yeah, a last point, if you have any question, go to our Slack community. You
Oh,
will
wow.
find me, you will find my colleagues in real time. Central Europe working hours. Well, I don't know if I have anything like working hours.
It's just life, isn't it? We just love our jobs, so that's the point.
What is this thing like work-life balance?
Yeah.
It's work-life fusion.
Awesome. All right. Thank you, everyone. Thank you very much, Gail, and thank you, everyone. I'll have a great rest of the day. And thank you. See you
Thank
later.
you. Have a good evening. Bye-bye.
Bye.